The next problem set question that I do from 5.11 is going to be your problem number 7, which is starting on the non-calculator section. So considering the right circular cylinder question, in the video it's problem 30, but in your problem set it is number 7.
So these are a little bit more challenging optimization questions that do not require the calculator. It's more problem solving. Okay, so let's look at problem 30. Consider all right circular cylinders, which is your standard cylinder, for which the sum of the height and circumference is 30 centimeters. What is the radius of the one with maximum volume? They're not giving me a whole lot of information here. I don't have any functions given. So this is the one where we have to come up with the function. If I want to maximize volume, I need to come up with a formula for the volume of this thing that's happening. Okay. So we've got a right circular cylinder. So that's your typical cylinder. So I'm just going to draw a little sketch of a cylinder here. Okay. Typically on the AP test, they will give you formulas for volumes of these shapes. But a cylinder, hopefully we know what the cylinder is. It's just area of the base times the height. So it's just pi r squared h. Yes. Hopefully we should all know that. Okay. So volume of the cylinder is pi r squared h. Okay, this might be bringing back memories of related rates, right? It's not a related rates, but it's kind of similar. It says, what is the radius of the one with maximum volume? We're not talking about the rate of change of volume with respect to time. We're talking about at what radius will maximize volume. So what I want is we want volume in terms of radius only. And then what we're going to do is we're going to take the derivative with respect to the radius because we're interested in how the radius is changing. Does that make sense? Not the time, but how the volume is changing with respect to radius. Okay. So I want to maximize my volume, but I need to get this in terms of radius only. So they give us other information to do that. They say the sum of the height and the circumference. Yes, Raj, you've done this with even in Algebra 2, you've done this type of skill set. But in Algebra 2, you would have done this work and then used a calculator to find the maximum. Or in pre-cal, we did that. But here, we can actually do this without a calculator. Okay, so we want to find when the sum of the height and the circumference is 30 centimeters. Okay, so we've got a height. And then the circumference. What's the circumference formula?
2r pi.
2 pi r, 2r pi. So if they're telling us that the sum of the height and the circumference is 30 centimeters, then we would say 2 pi r plus h equals 30. So there's our formula that relates h and r. And this just becomes like an algebra problem here. So I want to get this only in terms of r, so we're going to solve this equation for h. Now we can replace h in our formula. Okay, so now I have a formula for volume in terms of r only. So I want to maximize volume. So I want to take the derivative of this, set it equal to 0 for what values of r will give us a critical point, so on and so forth. Now, looking at this equation though, would you take the derivative right now as it sits? You could, but don't you think it would be better to go ahead and distribute? Yes. Sometimes you don't want to, sometimes you do want to distribute. Okay, so I'm going to go ahead and distribute, and I'm going to do this work over here on the side because I'm running out of space. So when I distribute, you get 30 pi r squared minus 2. Okay, here's I know some people get weirded out by this. You have pi times pi, which is just pi squared. Pi is not a variable, it's just a constant, and it can be squared. That's okay. Some people like freak out about that. So are y'all good with that equation? 30 pi r squared minus 2. Okay, so r is the variable. So when I take v prime, basically we're taking v prime with respect to r. It's not an implicit differentiation. You're taking the derivative with respect to r. So I'm going to even call this my volume as a function of r only. Okay, Take the derivative. That's not hard to do. Power rule. Pi squared, remember, is just a constant, so leave it alone. The exponent that you're going to bring down is the exponent on the r. So 3 times 2 is 6. Pi squared stays the same, r squared. Are we good with that? Okay. Now what do I want to do with my derivative?
Set it equal to 0.
Set it equal to 0. So set it equal to 0. To solve this, I need to factor. I'm going to factor out a GCF of 6 pi r. It gives me 10 minus pi r, I believe. Now, what's the domain of this function? What am I really interested in for r? For really, can r be negative? No. Okay, so really, I'm looking for when r is greater than 0. Do y'all agree with that? The interval in which I'm solving this, r has to be greater than 0. Okay, so this guy equaling 0, sure, on the normal equation is a critical point, but in this problem, I'm not interested in r being 0. So the only critical point I'm going to pick up is when 10 minus pi r equals 0, or when r equals 10 over pi. Now, if this was multiple choice, you're done, that's my answer. However, if this was free response, this is how you would say this. You would say, since r equals 10 over pi is the only critical point. Now, if I just stopped right there, it's the only critical point for v. Is that truly a true statement? That's not really a true statement. Good, yeah, well, because r equals 0 is also a critical point, but my true domain is for when r is greater than 0. So I would say, since r equals 10 over pi is the only critical point for v when r is greater than 0, right? Because I'm only interested in positive values of r. Y'all with me there? So that's now a true statement. 10 over pi is the only critical point for positive values of r. And since v prime changes from, now we didn't actually check this, but it's a good thing that you want to go back and make sure and check. V prime, does that in fact change from positive to negative? Don't just take that for granted. Make sure you do go back and check. So really, we're looking at this statement right here. So a quick check will show that that does in fact go from positive to negative at 10 over pi. Everybody with me there? Okay. And since v prime changes positive to negative at t equals 10 over pi, then max volume is when radius equals, I said t, it should be r, 10 over pi centimeters.